Alrighty then. Got a couple more routers here, don't we? Now with advanced EIGRP, why do we have this type of topology? Well, the reason that we set this topology because now there's two ways to get to, let's say let's call this the source and we'll call this the destination. So there's two ways you can do it. So EIGRP being the intelligent protocol that it is, it could load balance across these two lengths, right? Depending on what are those K values that we should already know, right? Bandwidth, delay, reliability, load, and MTU. And just so you know, for your CCNA again, that MTU, that's quite all right. You can say those K values, those 5K values are that. But in reality, the MTU, it is not. Okay, it is not. When you get to your other higher certifications, the MTU goes out the window. Okay, goes out the window. They don't consider it as a K value anymore. But for you that are taking the CCNA 200-120 routing and switching certification, those are your K values. And what do we have control over? Bandwidth and delay, really. But we're going to mess around with the bandwidth. Why? Because we are at the CCNA level. All right, and that's what they're going to ask you. All right, you're not going to have to do it, but I want you to see it and see what happens. Also, taking a look at now, since we have redundant links, we have the possibility of having a feasible successor. Now, as it stands right now, we're just going to put in, we're not going to do any housekeeping commands. That was in your previous lectures. All we're going to do is put in the IP addresses. Now, I do believe that the PCs already have their IP addresses in there. Let's open this. Well, we don't need to open that up, do we? 100.1 and 100.254. That's good to go. So we're good with that PC. This PC is 200.1 and 200.254. Remember, I used the first available IP address for the host, the last available IP address for the gateway. All right, but the routers are all off. So all we're actually going to do is just configure the interfaces with IP addresses and turn them on. That's the first thing we're going to do. Then we're going to go ahead and configure EIGRP. We'll call it Autonomous System 200 now. Okay, and then we'll see what happens. We'll take a look at the routing table. We'll take a look at the topology table, and then we'll see we have an actual feasible successor, yay or nay, and how to look at these K values. Now here we start from router 0, all right, and we're configuring F00 as 0000000 and S001. Too many zeros. All right, so let's go ahead and do router 1. So we go enable. You know what that means already, right? Set of mode. We don't have to worry about that. We're going to do config T. And we'll just call it router 0 since the title bar up here of this particular router says 0. We don't want to confuse anybody. So we'll call host name. Hey, I'm supposed to be typing in capital. Host name R0. All right, and that's about it as far as basic configuration, right? Let's go straight into the interfaces. Interface F0/0. Enter. IP address 192.168.100.254. 255.255.255.0, and we say no shut. All right, then we have interface S0/0/0. Enter. IP address. Now I want to make sure I got the right IP addressing scheme. It's the 10.1.1.1. Okay, perfect. Let's put it back up here. All right, it's 10.1.1.5 255.255.255.252. Slider 30. All right, this is an S000, or in my case, I always like to use that as a DCE. Is it the DCE? Let me check. Yes, there's a clock rate on there. Outstanding. Little clock, so there's the clock rate. All right, so we're going to put a clock rate. We'll put 4 million. 1, 2, 3, 1, 2, 3, and enter. And we do it no shots. Uh-oh. What was I thinking? Okay. And the other one is S001, if I'm not mistaken. Yes, it is. All right. Sorry to keep moving this out of your way here. All right. So now we do the int S0/0/1. And the subnet, I didn't memorize these. This is the 28 subnet, so 2930. This will be the 30 interface. IP address 10.1.1.30. 255.255.255.252. All right. This would be a DTE. I'm pretty sure of it. Let me move it again. Sorry about that. Yeah, that is. All my ones are usually DTE. I just do it that way. So we just do a no shut. All right. And enter. Let's go ahead and exit. Let's do it like you would in the test. Exit. And then do a copy, run, start. That's how you would do it. Right? Enter, enter. Right? Because that's in the brackets. Let's take a look at the show IP route to look at our routing table. And I'm only connected to one network, which is my LAN. And that's just fine. All right. So we're going to go this way first. All right, and we're going to come here, and we got the S001, and here we have a fast Ethernet 00. So that's going to be pretty easy, I think. There should be the 6, and there should be the 9. And I sincerely hope that you understand the IP schemes, okay, as far as this is 10.1.1.4, this is 5, this is 6, this is 9, this is 10, and so forth. If not, that's why the IPv4 addressing video is up there for you and Udemy to get. All right, so S001, that's the one we're doing now. All right. I'm going to say no. We'll give it a name. This is router 1. Host name R1. That's because that's what it says in the title bar. Interface S0/0/1. Enter. IP address 10.1.1.6. 255.255.255.252. Enter. And since it's a DTE, all I do is a no shut. And if it's the right interface, boom, change state to up. Okay. Now we go to the LAN. Int F0/0. It's not a LAN really. It's just a transit because it's going to another router. All right. So we put the IP address in there. IP address is the 8 network. So this is the first available IP address on that. That would be 9. 10.1.1.9. 255.255.255.252 and enter. No shut. And then we'll do right from here, do WR, and we'll do a do show IP route. Okay. And you can see we're connected to the 10.1.1.4 network, right, which is between router 0 and router 1, because again, we have to do the other router, router 2, in order to connect the 8 network. All right, so we're good to go so far. All right, now here we got the F01 and the S001, right? And this will be the 10, this will be the 13. So let's go ahead and do that. This should be no big deal for all of you. Enable, config T, host name, R2, interface F0/1, right? And then we're going to do the IP address 10.1.1.10, right? We have the 8 network, 9, 10. 255.255.255.252. Not there. A little extra number there. And then we do a no shut, and that state should come up. Outstanding. And now we go int S0/0/1, and the IP address there. See, we had the 8, now it's the 10, so this would be either 11. Yes. This is, oh, it's a 12. Sorry, 10, 8. Sorry, 9, 10, 11 broadcast. 12 network, 13. This is the 13. Okay. 10.1.1.13. 255.255.255.252. Oops, 252. And does this have a clock rate on here? No clock rates. Okay, just to verify. So just do a no shut. On there, do WR, do show IP route. Let's take a look at our routing table. If I can spell it. All right, and there we have connectivity between the 10.1.1.8 network, right? So we can ping within that network. So that's good. Okay. Now we go to this router right here, and we have 3 interfaces now, right? The 000, which is 14, the F00, and the S001. So the 000 is 14. All right, so let's do that. Say no, enable, config T, interface S000. That's what I like to call it. IP address 10.1.1.14, 255.255.255.252. Enter. Clock rate. We need a clock rate on this one. This is the DCE portion. We're using 4 million. 1, 2, 3. 1, 2, 3. Why do I choose that number? Because I can. This obviously is the physical speed, supposedly, of your information as it flows through that serial interface. And then I'll do a no shut. That state should come up. Very good. Interface F0/0. All right, and then IP address 192. I hate when that happens. IP address. That's why you do your basic housekeeping. 192.168.200.254. 255, 255, 255. In this case, is towards the LAN, an actual LAN. So we'll make it 0. All right, and then you do a no shut there. And then the last interface would be int S0/0/1. All right, IP address, and I believe this should be 17. Yeah, it's a 16 network right here, so this is 17. All right, let's bring this back here into view. All right, 10.1.1.17, 255, 255, 255, 252. DTE side, no need for a clock rate, no shut. Do WR, do show IP route. All right, now we're connected to 2 networks. We're connected to the 12 network, which is above us. We're connected to the 200, which is below us as far as the LAN, right to the right. And then, even though we do a do show IP int brief, right, we can't get to the other side just yet because it's down now. We unconfigured the other router. So let's go ahead and do that. So in this router, we have a 000, which is going to be 18, and we have a fast Ethernet. All right, so let's go ahead and do that. Say no. Enable. Config T. Host name. What is this guy? This is router 6, R6. And we go to interface S000. IP address 10.1.1.18. 255, 255, 255, 252. Clock rate, clock rate, clock rate, clock rate. 4 million, 1, 2, 3, 1, 2, 3. And if I did it correctly, it should come up. And I did. All right, interface F0/0, I believe. Let's verify, and let's verify the network. All right, so this is the F00, and we're in the 20 network, so this is going to be 21. Let's bring this back into view. Yeah, I apologize for taking all this stuff out of the screen. I was wanting to make sure where I'm at, make sure I'm there. IP address 10.1.1. It was a 20, so it was a 21. 255.255.255.252. Point to point, not an actual LAN, transit. All right, and then we're going to do a no shut. All right, we're going to do WR to copy. As you know, you got to go back to privilege mode and do a copy run start. Undo a do show IP route, and we're connected to the 16 network, which is above us. Outstanding. Let's go ahead and go now to this middle router, the 20 network. So this is 22, and this will be 25. F01 first, right? So let's do the F01. You know, you're not going to be moving it because I forget from one moment to the next. Config T, host name, R5, okay. Interface F0/1, IP address 10.1.1. I told you I would forget. That's just me. It's 20, 21, 22. You see? 22. 255.255.255.252. No shot. And the change state to up. So obviously the next interface, I'm just going to up arrow, put 0. All right, so now it was 20, then it was 24, so there should be 25 IP address. Oops, one too many S's. 10.1.1.25, 255, 255, 255, 252. No shut. And remember, if you put an incorrect IP address and mask, your router will let you know. All right, so that will be that. We only have two interfaces there. Do show IP route. And then boom. All right, we're connecting the 20 network. All right, let's minimize that router. All right, so we did this interface. This is 25. So this F01 is 26. So let's go ahead and do that one. No. Enable config T host name R4. Enter. Okay. Interface. My God, do I need some lingo before? F01. All right. F0/1. Enter. IP address 10.1.1.26. Yes, 26. Wow. 26, 255, 255, 255, 252. No shut. Please come up. Thank you very much. And then the other interface obviously is F0. No, that one's the serial interface actually. It's interface S000, if I'm not mistaken. And it's the 28 network IP address 10.1.1.29 because the one above, I believe I put it as 30. We'll soon find out. And clock rate. Hey, come on. Clock rate 4 million. 1, 2, 3, 1, 2, 3. No, 1, 2, 3, 1, 2, 3. 1, 2, 3. Yeah, okay. No shut. All right, change state to up. Do WR, do show IP route. That should be connected to two networks. And I'm not. Do show. Oh, okay, took a bit there. There we go. The 24 and the 28. I guess I'm moving faster than the router can think. All right, so we now have connectivity between each other. We don't have full connectivity going across. So obviously now we need the routing protocol. Now, it's pretty much the same command all around except for the LANs where we add another network. You can really copy paste. I'm not going to do that, but you can have a notepad file with the commands and copy paste and change accordingly. All right, but we just do it from scratch. Here in router 1, it's going to be pretty simple. We're going to be using the 200 for EIGRP autonomous system. So router EIGRP 200. Network, I'm going to do the LAN first because this has a LAN 192.168.100.0. Then the serials or the WANs, the transit, right, is class A, right? 10.0.0. And then no auto. I'm going to tab it out. Boom. All right, I'm done there. Do WR. I remember autonomous system 200. So in this one, it's really, even though you're connected to new networks, it's a class A address. So the class full boundary is 10. So you're only going to really have one network statement. Let's exit out of here. Router EIGRP 200. Network 10.0.0. And here we go. Boom. Build the adjacency. Tab it out. Do WR. Do show IP route, right? So we can see. And then, boom, now we see we're getting these, right? We're getting these from the 10.1.1.8.28 and the 192.168.100. So far, so good. Go to the next router. Same thing. You see how this is just repetition breeds retention. Do it over and over and over and over and over and over and over again. Router EIGRP 200. Network 10.0.0. No auto summary. And then I'm just going to do WR instead of a copy run start. Okay. And let's just keep going. Here now we have a LAN. We got to advertise that LAN. Okay. So let's exit out of here. Router EIGRP 200. Network 192.168.200.0 and network 10.0.0. Boom. No auto summary. There we go. Lovely. Do WR. Let's copy that. And let's come here. Same Same thing, except one less network. So router EIGRP 200 net. Let's start abbreviating because this is getting okay. It's the same thing. No auto hyphen summary UWR. Okay, you see, no biggie, no biggie. It's what you need to understand what EIGRP is doing. All right, and that's what the CCNA class will explain. Router EIGRP 200 net 10,000. Oops. No auto summary. Wow. Talk about abbreviating. All right. DWR. And then, all right. Last router. Exit router EIGRP 200 network 10,000. Lovely. No auto summary. Do WR. Outstanding. I'm going to do a control Z on that one. All right. So now we've configured EIGRP on all the routers. So let's take a look at this router right here. Okay. Let's take a look at this router 0. Let's take a look at its topology table. You see it's creating neighbor relationships, right? All right. So let's see who he has. Let's do a control Z. And let's look at the topology. Let's take a look at the routing table. I'm sorry. Show IP route. And there you can see that we're learning about the 10.1.8, the 12, the 16, the 20, the 24, and the 200. Now, if you look at the 200, which is the destination we want to get to, you see that it's going via the 10.1.16. So it's going up, not down. Okay? So apparently this is the best route for that particular router. So let's take a look at the topology table, which is where our feasible successor exists, our backup route. So show IP EIGRP topology. Okay, and let's take a look at everything. Oh, look how interesting. Here we have two ways of getting to the 200 network. We can go through the 6 or through the 29. But which number made it up there? The 268-6976. 268-6976. Okay, here's a 268-9536. So this is a bigger metric, right? A bigger feasible distance. So therefore, it is a backup route. It is a feasible successor. All right, in case this route goes down, it will then query the topology table and then place it into the routing table. There's a process and steps which you don't need to know about right now. All right, all you need to know is just that. Hey, I lost the route going this way. Do I have something in my topology table? Why, yes, you do. Well, I want to query it. I need it. Okay, not a problem. Let me place it on the routing table for you. All right, so that's what it does, and that's what you need to know at this point in time for your CCNA. So we do actually have a feasible successor, and you can see by the routing table that it was going via the 10.1.16, which is this. Now, we all know that the packet tracer, or should know, has this handy dandy little tool right here, right behind real time. It's simulation. And what you do is I click on the simple PDU, and I click on the PC0, and then I move my thing over and I go to PC1. And what I'm doing is I'm trying to see, okay, which way is it going? I want to verify. You can do a trace route, obviously, but it just looks cooler with the packet. Now you can see that it's going to be ICMP and ARP. That's the first thing that's going to happen, right? It's a ping, so it's going to do an ARP first, or whatever you're going to do is going to do an ARP first. So let's go ahead and do an auto capture play. And let me put it this way, because this is what we really care about. We want to know which way it's going. So let's go ahead and do that. There is your ARP, and you can see it there in the other pane, the simulation pane, the panel. And now comes the ping, the actual ping. It should go up according to our routing table. Let's find out. And there she blows. Okay. Now you got to think about what's going on here. there's more routers down here than there is up here. So using bandwidth and delay, there's more delay through here. We'll take a look at that in a second. Than there would be up here because you have less routers. So you have to go through more routers. All right. And let's see which way it goes back. It should still go up because, again, there's more delay going down this way. And as soon as that goes up, I'm just going to, okay, just went haywire on me. Okay, not a problem. Let's just delete this. Not a big deal. All right, let's go back to real time. So if you look at the routing table here, let's take a look at that. Let's see why did it go haywire there. Show IP route, I mean the router in the other LAN. All right, and the 200, oh, I'm sorry, to get to the 100, we're going via the 13 network, via 13. Well, 13 is this way, correct? This is 13 going up to this particular interface. So it will actually go back up again, all right? Just packet tracer being packet tracer. So what we're going to do, we're going to manipulate the bandwidth. It was just something that you really don't do in a real world environment is manipulate the bandwidth. You will really manipulate the delay. But for your CCNA, here I go again, for your CCNA certification, bandwidth is what you're manipulating, okay? So you're going to go in here, and we're going to take a look at what the bandwidth, and how would you look at that? Show interface S0/0/0. Enter. And here are your K values. There's your MTU. There is your bandwidth. There is your delay. All right, in tens of microseconds. All right, here's your reliability. And there are your loads. Okay, so all we're going to mess with is this number. Right now, this is the interface that is going up. So we want to make it do the opposite. We want to make it go down this way. And usually what I do, I can change the bandwidth along all routers. But all I'm going to do is I'm going to change the bandwidth on this interface and on this interface. All right. And then on this interface and this interface. And I'm going to make it go down this way. All right. So let's see if we can do that. So we're going to go, this is a bandwidth of 1.544. All serial WIG2Ts R is that bandwidth. Okay. So all we need to do, let's turn it into a 64K going up. All right, so we're going to go config T interface, interface S000. Okay. Now again, I'm gonna put a question mark there, and there's many things that you can do. You can see the delay. That's really what you want to mess with. But for our purposes, for the CCNA, we're going to mess with the bandwidth. So bandwidth, we're going to make it a 64 kilobit chunk. Okay, 64 kilobits. And hit enter. All right, I'm going to do WR. Okay, and in the one beneath me, interface 001, all right, which right now is 1544. Let's turn that into, again, bandwidth, and just so you can see, you put it in kilobits per second. So I usually put the maximum, but I like to exaggerate sometimes. So let's put in, I don't know, 6, 1, 2, 3, 1, 2, 3. All right, 6 million. All right, so if we do that, show IP in brief, make sure there are interfaces, because sometimes the packet tracer gets a little whatever, and both sides. Okay, so both sides are up, but just to look at the interface, show interface S0/0/0, you can now see that the bandwidth is 64 kilobits, and the other one, S001, is 6 million. 6 million. Okay, so let's go ahead and do the same thing for this. Let's turn this into a 64, turn this into a 6 million. All right, and which interfaces are those? 000 and 1? Yeah, same thing. Okay. So we're going to go into our, make sure I'm in here, config T, interface S0/0/0, and then we're going to do bandwidth 64, and then 1, and then we do bandwidth 1, 2, 3, 1, 2, 3, 6 million. Let's copy that, do WR, do show IP int brief. I'll keep copying. Hopefully, okay, cool. All right, you can see everything is still up. But now, let's take a look at the routing. Right, let's go back to our first router, router 0. All right, and let's see, after EIGRP did its calculations, let's see what it's coming up with. Show IP route. Now, we're going to the 29. No longer are we going to the 6 going up. So let's do a show IP EIGRP topology, right? And we want to go to the 200, and we still qualify as a feasible successor. But now this time, you see, look at the difference between the numbers here. Look how big this number is compared to this particular metric. That's why I chose that metric to be in the routing table and chose this metric to be in the topology table. All right, well, let's do our little trick again, right? Since that changed, and well, this one should have changed too. So let's take a look at this one also. All right, let's exit. Let's stay over here. Show IP route. And you can see to go to the 100 network is going to the 18. So the 18 is going down. And then we do the show IP EIGRP topology. All right, and we're going for the 100 network. You see that, yes, indeed, there's 2 feasible successors. You can see the math is pretty much the same. Okay. All right, so let's verify. I'm going to use my handy dandy simulation mode because it's just cool. All right, go to the PC 0. Go right there. Now it's just a ping, no ARP. So it should go down both ways. Just auto capture and play. There we go. It's going down. Let's follow it. Let's see what happens. We know it's only going to go one way there. Remember, that's your transit network there. So that's why I didn't even change anything in there. It really didn't matter. It mattered right at the routers where you were at. Okay. All right. There it goes, and made it to the other PC. Well, I will in a second. All right, let's see on the return trip. It should take the same route. It should take the same route because you saw it in the routing table that is pointing downwards. Let's see what happens. Boom. Perfect. So it's working like we want it to work. Again, verification, verification, verification. All right. This lab was just really to show you because you already know how to configure EIGRP, right? It's the same thing. The other thing is that you can manipulate it using bandwidth. Real world situation, you will really manipulate the delay because a lot of things could go wrong with applications, stuff like that when you start messing around with the bandwidth. But for your purposes in taking the CCNA exam, bandwidth, bandwidth, and bandwidth. That's what you're looking at. So here's EIGRP. No big deal. I'll see you in the next lecture.